Hi, everybody in Research Methods, Psych 290. Well, this is exciting. I don't know about you, but it is for me. Lab number 7 is the first one where we actually enter data. This is very relevant, not only so that you know how to do this as a skill, but also for your paper. You are hopefully in the process of getting surveys out to people and getting them back, and you're going to score your survey and compare it to other number scores, whether it is correlating with the person's age or comparing males to females with regard to their survey score. Well, Lab 7 is going to address the latter example, the t-test. So let's get started here. When you pull up Lab 7, it will look like this. One of the smart links, or hypertext as it's known, will be today's lab. You click on that and you'll see what the assignment is. But then you're going to enter it in VassarStats. VassarStats is the program that we're going to use. It's not pretty, it's not fancy, but it does the job. There are plenty of vendors out there, sales companies, that want us to force you to buy expensive statistics, and or statistical packages for your statistics. I don't have you do that. Instead, we use a free one. I like to keep costs down. The reading packet is inexpensive compared to most books, and this program, VassarStats, is actually free. So you click on where it says today's lab, and this will pop up. That is today's assignment. So let's go through these one by one so that you know how to enter data in VassarStats. This is a test that Biagio did in 2009. He wanted to know, when you watch a news story of something that is really infuriating, makes you mad, who admits to having more anger-related actions, males or females? And here's the score that he got from them on a 20-point test of anger reactions, males versus females. Now, it says he predicted, but if you're stating your hypothesis, it's in the future tense, because we haven't done the research yet. You don't have this data yet when you make a hypothesis. So his hypothesis here, getting a little ahead of myself, on A, state the null hypothesis. There will be no significant difference in anger reactions between males and females. Then enter your data on VassarStats. That's what it tells you to do next. So let's go back here. I would click on VassarStats, and when it pops up, it would look just like this. Now, what do? This is so confusing. Look at all these choices. Well, we are doing a t-test. So I would click on that. T-test. Then, what kind of t-test? We're not doing confidence intervals or single sample, and we're not going to do it in Spanish for this class or anything else, or ordinal data. This one. 2-sample t-test for independent or correlated. I don't like that word correlated because it makes it sound like it's a correlation, and it's not. That means dependent t-test. Correlated. So it's only one link, isn't it? You click on it and it will look like this. Well, let's go back to that data. Males versus females. There's their score on the anger test, right? So I'm going to go back and you'll see that I've already entered the numbers. Actually, I lied. I had some help. Family members helped me enter the data. So there it is. Those are the same numbers that we just looked at for Biagio's study. So I want to click here on independent samples. That's very important, that I'm looking at Group A versus Group B. Independent samples. Now, wait a minute. Is it a problem that I had more males fill out my surveys than females? The answer is no. As long as your numbers are close, it would be ridiculous if you had 300 males and only 2 females. That would skew your data, right? You would have an internal error. internal validity problem, but this is not a big deal. We had close to the same number of males and females, slightly more males. So it's important you click on independent t-test, independent samples. Then calculate. You're going to be doing this with your survey scores. Are you going to compare males to females? Well, this is exactly what you would do on your survey score. Or people who have a job versus people who are not working. Or I don't know, what else could you do? Gamers versus non-gamers, whatever your topic is. People who live at home versus people who don't. Well, once you get everybody's survey score in there, by the way, when you get to the last number, a student figured this out. I was very impressed with him. You don't push enter. That creates another cell and it thinks that that's a 0 score. So you just leave it like that. Does that make sense? Calculate. Wow, look at that. This is so much easier than Psych 230 where you had to do it all by hand, don't you think? These are the numbers, because remember, you need 2 hypotheses, and then you address your results in the results section and at the end of the paper in a table, chart, or graph. So a data table is so easy to do because these are the only numbers that you are going to need to report here. Let me show you which ones. N, I want to report that. I had 9 females and 11 males. I want to report the mean for each group. 14 for males, and 12.7778 for females. That's hard to say, by the way. So that is something I want to put in a data table. That's so easy to do. You type the numbers you found, tab over, click on to the next line. It's really pretty easy. So 14 is higher than 12.77, right? Males are more angry than females after seeing a news story. But is it statistically significant? I also, in my data table, want to report the t-score and one tail. So setting my alpha at 0.05, let's go back to this, if I can get it up on the screen here. Or maybe not. Okay, setting my alpha at 0.05. There it is. Took me a minute. Test the null with 0.05. So what did I find? What I found was that I have almost 20% room for error. I wanted to be at 0.05 here or less, but that did not happen. So what was the problem? Well, we'll get to that in a second. I am only 80% sure that males are really more angry than females when seeing an infuriating news story. I have 20% room for error almost. I'm only 80% sure, slightly more. That is not statistically significant. That's what I found. So back to the assignment. D, what can I conclude at the 0.05 level? I would have to accept or retain, same thing, the null hypothesis. Males and females are not statistically significantly different. Males are slightly more angry than females, apparently, looking at the news story, but not statistically. Now, E, what if a similar study found using 1,000 random people that there is a difference? Men and women from another campus, yes, I would change my results and I would say I made a type 2 error because males and females are apparently different, but I didn't capture that. How come? I didn't use enough people. That's called a type 2 error. Now, let's do the next one. Burke and Greenglass. I like this quote. It may be lonely at the top, but it's less stressful. Well, principals are the bosses, right? Yeah, you got a school board and the PTO, but you know what I mean. The principal's in charge. Well, how much burnout do they feel? It is estimated that principals have less burnout than teachers. So the null hypothesis, remember that's a statement statistically saying there will be no difference. There will be no statistically significant difference between teachers and principals and how much burnout they have. So enter the data. Let's go to the next VassarStats. Here is the data. Teachers, principals. Wait a minute, why do I have so many more teachers in my study than principals? Well, in real life, there are more teachers than principals, so that is not a problem. I'm going to click on independent samples because it's an independent t-test, two separate groups. Now, what if one of my principals says, you know what, this is a small charter school, I'm also the PE teacher. I can't use that person. You have to be in one group or the other, not both. So I clicked on independent samples, and what did I find? This is so exciting, isn't it? Calculate. 13 teachers, 8 principals. What is it that I'm going to be reporting in my study? This, N, and the means. Oh my goodness, look at this. The average burnout for a teacher is over 34 points of burnout, whereas for principals, less than half of that, only 15.5. Yeah, the teachers are way more burnt out than the principals. I am also going to report the p-value. Right here, less than 0.0001, so I am 99.99% sure of my results. That's interesting. I have less than 1/100th of a percent room for error. It sure looks like these teachers are way more burnt out than the principals, wouldn't you say? Moving right along. What can I conclude at the 0.05 level? Enter the data, did that, I would reject the null, reject H0. There is a statistically significant difference. That statement on A that said that there would not be turned out not to be true. I rejected the null. There is a significant difference statistically between teachers and principals. That's D here, what I can conclude at the 0.05 level. Now, hold up. Look at E. What if I later found out most of these teachers had been teaching for many years and the majority of the principals were brand new first or second year principals? I would say that is a type 1 error, a biased group or biased groups of people. See the problem there? I do. I thought I had something hugely significant, but it turned out not to be true. Now, let's look at the next one. Addison from 1975. Bearded men. Guys with beards, do we perceive them differently? More masculine, aggressive, dominant if you got facial hair? Well, the null hypothesis would say there will be no significant difference. But wait a minute. Let's look at this real quick here. Let's not get ahead of ourselves. What does it say here? Before and after shaving. Now, this study would take forever if we were waiting for all these guys to grow a beard. Instead, we see them bearded and then they can go into the bathroom and shave and then we look at them again. How masculine, dominant, and aggressive does the guy look? Well, guess what? This is not an independent t-test, is it? It's a dependent t-test. So the null hypothesis would say there will be no significant difference before and after the men shave. Enter your data. Well, let's go to VassarStats and take a look. Here's the data. Notice the columns do have to add up because it's a before and after study. What am I going to click here? Dependent t-test is correlated samples. So make sure you click that first and then calculate. Good, 11 and 11, it's the same people before and after. That's necessary. That makes sense. Oh my goodness, look at this. These are the numbers I'm gonna report. There is almost no difference. The males looked slightly more aggressive and masculine before they shaved than after, but really, that's very little difference, huh? I'm going to report the t-score and the one-tailed value. If I didn't mention that before, you do want to say what t is, but what about the 0.25, round that to 0.26. I am not even 3/4 sure of my results. That is a lot of room for error, huh? Because it sure looks like I'm going to accept the null. I'm going to fail to reject the null. Same thing. There is no significant difference. So let's look at the question here. What if you later discovered that study is old school, huh? That's an old one. A recent nationwide study on facial hair in men showed that there was no differences in perception from today's college students. Therefore, Addison's ideas might be outdated. No, they're not, because we did Addison's data from 1975, that was forever ago, and found no significant difference. This modern study found no significant difference. So what is the answer? The answer is decision correct on that 4-square chart that we went over in the video and the reading packet. We did not find a significant difference, and that's what we expected, and that's what later data showed us. So therefore, not a problem. So see, this should come in handy because you're going to be entering data in VassarStats and then constructing a data table if you're using a t-test. I don't think I have any of you doing dependent t-tests before and after some event. Instead, it would be much more common that you would be using independent samples, such as male versus female, or people who are full-time versus part-time in their jobs. So that is it for this one. Take care.